Hello everybody, welcome to my Project Euler.net video tutorial series. Today we're going to be working on problem number 5, which right here is stated that 2,520 is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. What is the smallest positive number that is evenly divisible by all the numbers from 1 to 20? Well, if you're a little unsure of how to go about this, you might do what I did the first time I encountered this problem, which was basically to just multiply out, all the numbers from 1 to 20 and, see what that gets you. And you'll find out it's not the right answer. And then I tried it for 1 to 10, and I didn't get 2,520. I got 3,628,800, which a lot bigger. To understand why that is, we need to understand the fundamental theorem of arithmetic, which is a pretty important sounding name, but basically it just says that every number is a unique product of prime numbers. Basically, if you think of, say, a number as kind of like a compound, like a chemical compound, and a prime number, which, if you're unfamiliar, is a number that's only divisible by 1 and itself. It can't be made any smaller. Well, if a prime number is kind of like an atom, a number is made up of atoms. It's made up of those prime numbers. So let's just do an example. Hopefully, it's a little clearer. So if we have 12, 12 is made up. You can have two groups of 6. Well, you can't make 2 any smaller. You can't divide 2 evenly with any other number. But you can with 6. You can divide it into two groups of 3. So 12 is the product of primes 2 times 2 times 3. And it sounds kind of silly to state it this way, but basically what the fundamental theorem of arithmetic says is that 2 times 2 times 3, the only number that will ever equal is 12. And the only way you can get 12 using prime numbers is by using 2 and 2 and 3. Which, incidentally, if you've ever wondered why 1 is not considered a prime number, is because besides having 2 times 2 times 3, you could also have 1 times 2 times 2 times 3, or 1 times 1 times 2 times 2 times 3. So mathematicians basically decided they liked their fancy fundamental theorem of arithmetic more than they did 1 being prime, so long 1. Now, the atoms that make up this 12, any number that also is made up of these atoms will divide by 12. So, like, for example, 4 is made up of 2 and 2. So we know that 4 is going to go into 12 because 12 also has the atoms 2 and 2 in it. You can do the same with 6. 6 is 3 and 2. Just to try and make this a little clearer, let's look at 60. 60 is 2 and 30, which is 2 and 15, which is 3 and 5. So 60, the unique product of primes that make up 60 is 2, 2, 3, and 5. Well, we can see here that we can make 12 out of these atoms, so we know that 12 is going to go into 60. So what does that tell us? What it tells us in terms of our original problem is, if we go back to it, if we want to make up some number and we want it to be the smallest number that contains all of the elements that can make up any of these numbers, we need to find the prime factors of each of these numbers. And then we're going to list them here, and those prime factors are going to make up some number. And we're going to see if this number it makes up is 2520. So let's start with 1. Well, 1 isn't a prime, so we don't have to worry about that. And it makes sense, right? Because 1 times whatever else we're going to put is just going to be the same as whatever else. 2 2 is a prime, so we'll list it here. 3 is also a prime. Well, 4 we know is made up of 2 times 2. Well, we've only got one 2 here, so we need to have another 2 in order to have the elements required to make up a 4. 5 is prime. 6 we just saw is 2 times 3. Well, we've got a 2 and we've got a 3, so we already know that this number we're making, 6, is going to be divided evenly into it. 7 is prime. 8 is 2 times 4, which is 2 times 2, or 2 to the third. So we need 3 2's in order to make the number 8. Well, we've only got 2 here, so we need to add another 2. And 9 is similar. It's 3 squared, 3 times 3. So we need 2 3's. Well, we've only got 1, so we need to have another 3. And 10 is 2 times 5. We've already got a 2 and we've already got a 5. So this right here is the smallest set of primes we can have whose product, any number from 1 to 10 we can make with these numbers. And this is the fewest primes we can use to do that. And if you multiply this out, you'll see that it equals 2,520. So now that we've got the smaller, the easier, and that's the nice thing about Project Euler. They always kind of give you a simpler one, so you can check to see if your approach works. And it might not give you the harder one, because it doesn't always scale up. Sometimes you need a more efficient algorithm, but we're not using code here. We're just doing it by pen and paper. So let's scale it up ourselves. Let's just see if we do 11 through 20, continue with 11 through 20. Actually, let me undo this. If we keep adding elements so that we can make up each of the numbers 11 to 20, what will we end up? Well, 11 is prime. 12 is 6 and 2, which is 2 and 3. We've already got all those in there. 13 is prime. 14 is 2 and 7. We have 2 and 7. 15 is 3 and 5. We've got a 3. We've got a 5. 16 is 2 and 8, which we know is 2 cubed. So 16 is 2 to the 4th. Well, we've only got 3 2's here. So in order to have the elements necessary to make 16, we need to add a 2. And let me actually get rid of this. Pen back. Okay, so 17, that's prime. 18 is 2 and 9, which is 3 and 3. We've already got all those. So we need 19, which is prime, which you can check for yourself. Try and find a smaller way to make that. That's 2 and 10, which is 2 and 5. So that's it. Contained within here are the elements required. We can make any number from 1 to 20, which means that 1 to 20 will divide evenly into whatever this number is, which if you multiply all that out, 2 times 3 times 2 times 5 times 7 times 2, blah, 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 that number you get should be the answer to this problem. So that's it. If you have any questions, any comments, anything was confusing, let me know, leave a comment. And also, this video, probably too long. Again, watch my earlier video, which I'll link to in the description, which shows you how to speed up YouTube so you can listen to people like me ramble half as much and still get all the information. Thank you.